or until we reach to the end of the data segment 1000. And finally, in the destination, the TCP can use the segment numbers to recreate, okay, and also renumber the data into the original data. And maybe in some cases, some of this data are lost in the past. Because of that, the destination TCP can request that I need, for example, segment 4, please send it again. You will learn about all of them. But for now, let me to say that here, after creating the data with FTP for and making ready for sending, we need another type of protocols in the transport layer, okay, in the transport step, to make ready the data for transportation, for example, about the segment size and also about the other things we will learn about all of them in the future. Because of that, here we need some other protocols, we call them transports. Two of the most famous transport layer protocols are TCP and UDP. Some applications, as I mentioned before, are using the TCP and some applications are using the UDP. These two protocols have some differences. Because of that, we learn about these differences. But let me to say that in most cases, when we need to send the huge amount of data, we are using TCP, and when we are using the less data or with the requirement about the quality, we are using UDP. You will learn about this. And here we have the TCP and UDP in the transport layer. And also let me write here TCP and UDP. You will learn step by step everything, not in one step. Here we have two protocols, we don't have any priority between them. And here also we have many protocols, for example FTP, for example HTTP, or for example the SMTP, the POP3, or some other protocols. Okay, after that, after segmenting the traffic, we need to assign address to this traffic. So you know that we need source IP and destination IP in each segment. For example, in segment 1, we need to assign the source IP of the IP of PC1. Let me to use it IP1, and destination IP is the for example IP2. Okay, IP2 is the IP of the destination, or is the IP of the PC2. Okay, IP2 means IP of PC2. We need to assign the source IP and destination IP and also some another information to each packet. Because of that, we have another task, and this is the task of the one of the most famous protocols in the TCP IP. We call it IP. Okay, in the next layer, in the next function, we have the network layer. You know that in network layer we are using IP for addressing and also routing. This is the function of the addressing. Okay, because of that, now here we have the network layer. One of the most famous protocols in this layer is IP, but we have another protocols also in this layer. And after that, this is the network layer. This means that we have many jobs to forwarding the data to the destination. In the network layer, we have another protocols, for example IP or ICMP. You will learn about both of them, but IP is the most important protocols in the network layer. After that, now we have some segmented numbered and also some segmented addressed packets that we are ready to advertise them. But here we have some differences according to our media. You know that, let me write here, after the transport, we have the, for example, network. This is a conceptual diagram. Okay, look at here, we have many type of media in our networks. For example, between the PC1 and PC2, we can use the copper cable. You will learn about the type of copper cable in this course. Also, maybe you encounter with the fiber optic cables. Okay, and also today's we are using air for advertising the data with wireless. Okay, because of that, we have different type of technologies for sending and receiving data. And you know that here we have a data that we need to forward this data to the destination. This data has source IP and destination IP, but according to the physical line that we are using, we need to make ready this data with a little different for example, the task, because for copper you need a different technology to forwarding. For fiber optic, maybe you need to do something, and for air also you need different technology. You will learn about all of them, but here we can't send this addressed segmented data in all of these technologies in media with exactly the same function, same manner. Because of that, we need another layer. We call it data link. Data link means a protocol that we are using this protocol for making ready the data for advertising on the link. Look at here, the name of this protocol is, these protocols are data link protocols. Means their function is creating the data, is making the data ready for forwarding on different physical media. For example, we have one of them as Ethernet, another is the, for example, Wi-Fi. Maybe you learn about them. Wi-Fi is, Ethernet is working on the copper and also in the fiber optic, but the Wi-Fi is working on the air. Because of that, we need another type of protocols. Here it's not necessary to think about all of the detail of these protocols, because you need more knowledge, you need more for example, a study for understanding all of these features. But for now, it's a good time for thinking about overall or high level about the function of the protocols or steps in TCP/IP. Because of that, here we have another protocol. For example, we can use Ethernet. Ethernet is one of the protocols we are using in the TCP/IP for creating the data ready for sending on the copper. And also one other protocol is the Wi-Fi. Wi-Fi is the protocol that we are using that for advertising the data on the air. Maybe you learn about them. And also here we have Ethernet again, or Wi-Fi. Let me write here only Ethernet. This is the function of the data link, making data ready for advertising on the link. And also here we have the physical layer or physical part. In physical, we have some technologies. For example, about the copper, we have the fast Ethernet. For air, we have, for example, different type of air 802.11b, 802.11g, and other technologies. Okay, let me to write here only the physical layer. If you want, you can write here 100 base T. This is the for example, the twisted pair, 100 base T, the twisted pair cable we are using on the Ethernet copper, for example, a physical layer, or other technologies. Here, the detail of this information is not important for us. We are only talking about the overall function of the TCP/IP, why we need to TCP/IP. If the TCP/IP doesn't available, what is our problem? How we are using the TCP/IP with detail is the concept of future videos. Very good. Because of that, you learn in this part that according because we need to send traffic from the PC1 to PC2, we need some steps. First, application should receive the data, original data, and make it ready for sending to the destination protocol or destination application. We call it application step or application layer. After that, we need to create the data ready for advertisement, about the segmenting the data or some other things. Because of that, we need another protocols. We call them transport protocols, such as the TCP or UDP. After that, we need to assign address to the data. We need the IP address, or for example, IP protocol. Here is this is the function of the network layer. After that, according to our physical layer, we need to make ready data for advertising on the physical layer. Because of that, we need other protocols. We call them data link protocol. And finally, we can send the traffic on the physical layer. Here in the physical, also we have some another rules about the voltage, about the current of the physical media, and some other things about the physical layer. Because of that, in TCP/IP, we have 5 steps to advertising the data into the physical layer. And finally, in the destination, again, we have the same 5 layer. The first, in the physical layer, the data should be received. After that, this should be converted in data link layer to data. After that, the network layer can read the IP address. After that, the transport layer can receive the different segments, and finally it can recreate the data, renumber the data, and finally the application of PC2 can receive the recreated data, and now the original data sent to the PC2. Because of that, we have many steps for forwarding the data, and in some of the course we will learn about the, for example, detail of application layer. In other courses we will learn about the network layer, transport layer, or other layers. Okay, this is a TCP IP's function, but let me to talk about a little the OSI model. You know that OSI, okay, is the reference model, as I mentioned before. Now we don't use the OSI in our networks. We are using OSI as the network referencing model. Means the TCP IP and other models should be compatible with the OSI reference model, OSI, or the Open System Interconnection. Let me talk about a little about the OSI. Look at here. In OSI, we had these steps: application steps, presentation step. As you can see here, because these steps order start from the application, then transport, then network, then data link, then physical. We can imagine these steps as the layers. This is a layer 5. The first is the layer 5 because it is a higher level, such as a building. This is for example, level 5 or layer 5. This is layer 4. This is layer 3. This is layer 2, and this is layer 1 reaching to the ground. Okay, here in the OSI model we had 7 layers, as you can see in this picture. Let me write here. This is layer 7, this is layer 6, this is layer 5, this is layer 4, this is layer 3, this is layer 2, and this is layer 1. Look at here. OSI, for example, you know that OSI is another model, and in OSI, the designers of the OSI created these 7 models for sending the data. They said that first the data should be received by one application, such as the TCP IP, but this application should do some things, and after that the data should go to the presentation layer. Here we have another functions about the, for example, encryption or about the presentation. After that the data should go to the session layer with another protocols, and then to the transport layer, to the network layer, to the data link layer, and physical. But TCP IP, when TCP IP is created, TCP IP said, yes, I am compatible with the OSI model, but I want to do these 3 function: application, presentation, and session of the OSI model in only one protocol. Because of that, the FTP's function is the application, session, and session, application, presentation, and session function of the OSI model. Don't mistake. The application layer of the TCP IP is different